This last Thursday, a swarm of earthquakes began striking underneath one of the planet's most potentially dangerous volcanoes, specifically one situated on an island home to nearly 950,000 people. This occurred underneath a section of the towering Teide Volcano in the Canary Islands, specifically beginning in the afternoon at 5:20 p.m. local time on February 12, 2026. Centered about 3,500 meters southwest of Teide's summit, across the next 10.7 hours, a total of 511 earthquakes struck one after the other in a fairly rapid succession. These largely occurred at a depth of 10 to 12 kilometers, and with one exception, all of these events were classified as hybrid earthquakes. Hybrid earthquakes are called such because they represent a combination of volcanotectonic earthquakes and long-period earthquakes. In this case, caused specifically by the movement of underground fluids, and while this could theoretically have been caused by magma, it was not, being triggered instead by hydrothermal fluids. I have made two potential models which show possibilities on what caused this particular earthquake swarm. As something changed at this volcano back in 2016 when either a smallish intrusion of magma intruded into the ductile lower crust into a pre-existing magma reservoir, or as an upward-moving dike that traveled a short distance before completely stalling. Hydrothermal fluids have since then intermittently built on the very top of or just above the top of the failed intrusion, occasionally rising to 10 to 12 kilometers depth and generating earthquake swarms. This has produced noteworthy swarms 7 times, which each involved at least 150 hybrid earthquakes. So, with the Teide Volcano making the rounds in the news, the latest earthquake swarm must have been pretty strong, right? Not really. Its February 12th to 13th earthquake swarm actually ranks 4th out of these 7 swarms, marking it as just an uncommon and infrequent yet not totally unexpected event. Also, all of the earthquakes which struck were below magnitude 2, meaning it was impossible for any locals to have felt one or more of these quakes. Thus, the recent activity isn't some worrisome signal that Teide is about to erupt, as out of these 7 signals you would all expect to see in the days, weeks, or months leading up to an eruption, only half of 2 of these points have actually been observed. So, nothing to worry about. However, I did mention that one of these 511 earthquakes was different. In fact, it was the first of its kind to ever be recorded by the modern sensor network specifically on the Teide Volcano. It involved a continuous tremor signal which lasted for 90 minutes, but was not a harmonic tremor. I hypothesize that this signal may have involved the movement of a larger batch of hydrothermal fluids, or so many hybrid earthquakes or long-period earthquakes in a short time span that they might appear as one continuous signal. Regardless, I am pretty certain magma was not involved in that signal. While theoretically speaking, very small volumes of magma could be accumulating in the ductile crust, such isn't a requirement to explain the intermittent earthquake swarms. However, Teide is an active volcano and it has produced prior failed magmatic intrusions even quite recently, such as during 2004 to 2005 in its northwest rift zone. So, if magma is even vaguely involved in the recent earthquake swarms, it would either be primitive aka basaltic composition, or evolved being phonolite. I also want to note that there is the potential for increased gas emissions to occur sometime in the next 14 months because of the swarm in specific fumarolic areas, like seen in 2017 from the 2016 earthquake swarm. However, such elevated gas emissions were only detected in one of the other 6 prior hybrid earthquake swarms. Now for some background info about this stratovolcano. Teide's last 5 eruptions occurred in 1704, 1705, 1706, 1798, and 1909 at these shown locations. These historical eruptions have occurred in portions of 2 rift zones and in 1798 within the summit caldera of the overall volcano. The flank eruptions tend to only be moderately explosive, forming cinder cones and fairly fluid lava flows, while the caldera-confined eruptions tend to produce eruptions at least an order of magnitude more explosive, sometimes producing highly viscous lava flows. I hope that this quick update video can relieve any fears about this volcano that people might have. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.